Hello gentlemen, and welcome back to Prospect Charter School's Algebra 1B course, or the Algebra Skills course. Today we're going to be looking at finding the vertex of a parabola in more detail. So previously we've looked at y is equal to ax squared plus bx plus c. And what we need to be able to do to graph these is find the vertex and then use the Canadian saying. Now, to find the vertex, we first said x is equal to negative b over 2a, and then from there we would plug that in to find our y-coordinate. Now, sometimes we're not given this format. Sometimes we're given the easier version, which is called the vertex format. In vertex form, you'd be looking at y is equal to a on the outside of x minus h quantity squared plus k. Now, the nice thing about vertex form is that the vertex is already given to you. And that vertex is always going to be at h, comma, k. So for an example, let's say that I was given y is equal to negative 4 on the outside of x minus 2 squared plus 7. I would instantly know that my vertex is located at h, which is the opposite sign of whatever this number is. In this case, it would be negative 2, but because we're using the opposite sign, our x-coordinate would be positive 2. The k appears on the outside, so the k would be 7. So these should be review from previous lessons. The vertex form equation, x is equal to negative b over 2a, to find the x-coordinate of your vertex. Then you plug it in to find your y. The vertex format of a on the outside of x minus h squared plus k helps us find the vertex in that fashion. Now there's one more method of finding the vertex, and this is if we're given the particular equation in what's called factored form. If you'll notice, this is indeed fully factored. This is great for finding the zeros, because if you were to find the zeros, you take each piece and set it equal to 0. So you'd have x minus 4 is equal to 0, and x minus 2 is equal to 0, and then you have x is equal to 4, and x is equal to 2. But unfortunately, this isn't so good about finding the vertex. So we have two options. Option 1. Convert to standard form. And use x is equal to negative b over 2a. And then there's the second option, option 2. And option 2 uses the property of parabolas in that all parabolas are symmetrical. Option 2 says that the x-coordinate exactly halfway between the two zeros. Which means that we'd be using the midpoint formula. And the midpoint formula is A plus B over 2. So in this case, the midpoint formula for what we're given would be 4 plus 2 over 2, which is 6 over 2, which is 3. Now, double checking and using the standard form, or option 1, I would take my equation, y is equal to x minus 4 times x minus 2, and then I would FOIL and get x squared minus 2x minus 4x plus 8, which would get me x squared minus 6x plus 8. And then using x is equal to negative b over 2a, I would have negative 6 over 2 times 1, which is 6 over 2, 3. So when I'm looking at these, I really prefer option 2. The main reason for it is that it's a lot less work. And once I know what the x-coordinate of my parabola is, of the vertex of my parabola, I can plug it in to find the y-coordinate. So in this one, I don't even have to FOIL. I just plug in 3 for my x values. So I'd have 3 minus 4 times 3 minus 2. Let's see, 3 minus 4 is negative 1. 3 minus 2 is positive 1. So it would be at negative 1, which gives me the coordinate 3 comma negative 1 for my vertex. And the same thing with option 1. I'd plug in 3 to this equation right here, and it would give me the same output. Don't believe me? Feel free to do it yourself. So I prefer option 2, but again, this is personal preference. If you don't like option 2 and you can't remember the midpoint formula, feel free to convert it to something that you are more familiar with and use it. Alright, so here's what I want you to do. I want you to find the vertex of the following. And yes, there's going to be a lot of them, mainly because this skill is uber useful. So I highly recommend that you get a lot of practice on it. So here we go. Number 1, y is equal to x plus 2 times x minus 3, 2. So the first 5 are all in, well, 4 out of the 5 are in 0 format, fully factored format, and then these not so nice. And of course number 10 is truly evil, but I think you guys can do these. Alright? At this point, I would have the sub pause the video and have the students work through all 10 of them. Alright, let's go over these really quick and double check to make sure that our work is done correctly. So on this one, I'm going to use the midpoint formula, and what I would do is I would have a positive 2, and then plus, actually this would be opposite signs, so it'd be negative 2 plus 3. I believe that's how we did it before. Did we do it that way before? Let's double check. Yes, we did. Okay. 2 plus 3, which gives me a positive 1. So the x-coordinate of the vertex would be 1. The y-coordinate would be 3 times negative 2, which is negative 6. So for number 2, the same thing. 3 plus 5 over 2. So this would be over 2. This would be 1/2. Which would mean that wouldn't be the same thing. 3 plus 5 is 8 over 2, which gives us 4. Plugging in 4, we get 1 and then negative 1. So this would be at the coordinate point 4 comma negative 1. Negative 7 plus 7 over 2, which is 0 over 2. So that gives us 0. And then we have 7 times negative 7 is 49. So this would be at the coordinate point 0 comma negative 49. This one, there is no b value, so that makes it super easy. That means it's going to be at 0 comma negative 16. This last one, we're going to go ahead and do the same thing as before. Negatives plus 5 all over 2. Negative 6 plus 5 is negative 1, so this is negative 1/2. And that would make the, see, that would be 12 minus 1 is 11 halves. And this would be 10 plus 1 is another 11 halves. So this would be positive times a negative is a negative. Now the remaining ones, 6 through 10, should be super easy. Positive 3, positive 6. So this is at the location 3 comma 6. Negative 2, negative 5. So this is going to be at negative 2, negative 5. Positive 1, positive 3. So this is going to be at 1 comma. Alright, these are the last 5. Go ahead and practice them on your own. Again, at this point, I would ask the sub to pause the video for a few moments while they copy them down and try to get them done. Alright, let's see them in action. Remember, this is x is equal to negative b over 2a for all of these. So in this particular case, we have negative 4 over 2 times 1, which is positive 4 over 2, which is at 2. Get 4 minus 8 plus 3. 4 plus 3 is 7, minus 8 is negative 1. So the vertex is at 2, negative 1. For the next one, again, we have x is equal to negative b over 2a. Plugging them in, I get weird stuff going on there. There we go. 25 over 4 plus 25 over 2, and then minus 3. Now I want to have them with common denominators. I'm guessing that 4 would be the best one, so I'm going to turn this into 50 over 4, which would make this 12 over 4, because 3 times 4 is 12. Okay, then we go 75 minus 12 would be 63. So this one would be at negative 5 over 2, comma, 63 over 4. Moving on to the next one. We have x is equal to negative 6 over 2 times 1, which is, of course, 3. Plugging in 3, we get 9 minus 18 minus 5. So that would be negative 9 minus 5 is negative 24. So this one would be at 3, negative 24. On number 4, so we have negative 3 over 2 times 1, which is going to be another fraction at 3 halves. Plugging it in, we get 9 over 4 minus 9 over 2, which is plus 12 over 4. See, 9 minus 18 is negative 9 plus 12. 12 minus 9 is 3, so this gives me 3/4. So my vertex would be at 3 halves, 3/4. And for our last one, x is going to be at negative 2 over 2, which is negative 1. Plugging that in, we get 1 minus 2 minus 5, which is at negative 6. You guys have been an excellent audience. I will give you a few more to do for homework, and then we'll call it a day. And those are the following. I want you to find the vertex of these guys. Good luck, and have fun.